Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of inverse trig integration. As always, there are going to be some basic integrals that you must memorize, and here they are. The rest of this video will be conducted with a student. Unfortunately, I forgot to press one button, so therefore their voice cannot be heard. Make sure you memorize these formulas. Okay, so at first, they're pretty straightforward if we have the basic integral. But some of these, you'll be forced to complete the square, and it gets a little tricky if you don't know to do that. Okay, but if you've, done a little prep work and you've done some problems, the more problems you do, the more examples you see, the less likely they're going to trick you with a special type of problem because you will have done it already. Does that make sense? Okay. So in your steps of integration, you should always go down a hierarchy of lists. You should try to do them separately first. And if they're added, subtracted, then you can do them separately. Then you should try algebra. By that I mean long division or separation of numerators, what other foiling out, multiplying through, distributing, whatever algebraic trick you can think of. If it's trigonometric, this one's kind of on the same level as algebra, okay? Because if it's trigonometric, you can do trig identities. And then you should try U sub by parts, and then one of the special techniques or formulas. Okay, so if you are approaching this problem in the test, you should go, okay, they're not added, subtracted. There's no algebra I can do. I can't long divide. There's nothing to divide. There's nothing to separate, FOIL out. There's no trig for identities. There's no derivative of the more complex, right? What would I need up here for me to be able to do U sub? Yeah, what is du? What would du be? If this is u, go ahead. Good. So some sort of x should be here. It doesn't matter. It doesn't have to be -2 times x, but just an x to the first power. Since we don't have that, we can't do U sub. Okay. So, and that there's nothing to really do with IBP, so we try one of our special techniques, and you hopefully, way before you got all the way down that list, recognize this as an inverse trig formula, because you've done so many of them to practice, and you remember that the arcsine, cosine, tangent, cotangent is one of those. Which one is it? Sure, no problem. I said we have, it's going to be one of the basic formulas. Which one is it? Arcsine, cosine, cotangent, tangent. Which one is it? Arcsine. Good. So what's the general formula? No, just the answer part of it. Arcsine of, sure. I'm gonna use, that's fine. U is perfectly okay. So the way you figure out what's going on is you let your box squared equal your variable, whatever your variable is. So square root both sides, your box is x, or your u squared can equal x squared, that's fine. And then a squared will equal 9, and a is as a result 3, so your final, yeah, good, perfect. So then we have arcsine of x over 3 plus c. Any questions there? I hope this has clarified your fundamental understanding of the inverse trig. Like I said earlier, it can get a lot more complex, completing the square and such. So if you need to review that concept, please go back and watch that video or do problems, whatever you need to do. All right? But as always, you just need to practice these. The more you do, the easier they'll be. And then you will have less room for surprise and be very efficient. So practice, practice, practice. Thank you and have a nice day.